In this video, you will learn to problem solve using consecutive integers. Now, as we get into this, we need to first determine what our terms mean. So first, what is an integer? Well, an integer is really any number that does not involve a fraction. So for example, like -3, -2, -1, 0, 1, 2, 3, etc. would all be integers. If you had fractions like 1/2 or -2/3 or 4 and 1/5, those would all not be integers. All right, so when we say consecutive integers, what we mean are integers that are one right after the other. So they can be found by counting by ones. So for example, 3, 4, and 5 would be three consecutive integers. Or it could be -3, -2, -1, or -12, -11, -10. Those would all be consecutive integers. When we say even integers, that could also include negative numbers. So it could be -6, -4, -2, 0, 2, 4, 6, etc. Those would all be examples of even integers. Odd integers would also include negative numbers, such as -5, -3, -1, and also the positive numbers, so 1, 3, 5, etc. So example 1, we are told the greatest of four consecutive integers is 13. And what are the other three integers? Well, if the biggest one is 13, the other ones would have to be 12, 11, and 10. So the four consecutive integers would be 10, 11, 12, 13, where 13 is the largest. Example 2. We are told that k equals 10, and we are to represent 7, 9, and 13 in terms of k. Well, for 7, we know 10 minus 3 equals 7, right? Well, we also know that 10 is k. We're told to write in terms of k, not 10. So instead of 10 minus 3, we want to write this as k minus 3. All right, so that's my expression for the number 7. Same thing for 9. For 9, we know that 10 minus 1 would equal 9, right? So instead of 10 minus 1, we want to put a k in there so we can write it in terms of k. So instead we would have k minus 1. And then for 13, if we add 10 plus 3, that would give me 13. So instead of 10 plus 3, we're going to replace it with k. So we have k plus 3. Next, we're told that an integer is represented by n. And we are told to write the next three integers in natural order after n. So we know the first number is n. So the next number is one more than that, which would be n plus 1. And then the next number is one more than that, which would be n plus 2. And then the third number after that is one more than that, which is going to be n plus 3. So I can write this as n plus 1, n plus 2, and n plus 3. Those are the three next numbers. So n could be anything. So if n were like 5, the next number is one more than that, which is 6, and then followed by 7, and then by 8. All right, so that's what that means. N can be any number. It doesn't need to be 5, but we know that the following numbers will be increasing by 1 each time. Next, if we are told that the integer, or we're told to write the integer that immediately precedes n. So precede means the number before. So let's say, for example, the number is 11. The number before that would be 11 minus 1, which is 10. So we find the number before by simply subtracting 1. So if I take the letter n, subtract 1, that is the number that immediately precedes n. Next, we're to write an equation that states the sum of four consecutive integers starting with n, and that the sum is equal to 54. So we have 4 consecutive numbers. So if we let the first one be n, we're starting with n, then the next number after that is 1 more than that, which would be n plus 1. And then the next number is 1 more than that, which would be n plus 2. And then the fourth number would be n plus 3. And it says here that the sum of these, so the sum of n and n plus 1, n plus 2, and n plus 3, would be 54. So I can add n plus 1 plus n plus 2 plus n plus 3, and that is equal to 54. So we're not solving for this one, we are simply writing the equation. Later, we will learn how to solve different equations. Next, we're told that an integer is represented by n, and we are to write 3 consecutive even integers. So consecutive even integers would be something like 8, 10, and 12. Okay, they're numbers that come right after each other, but they have to be even. So 8, 10, and 12, or 14, 16, 18, something like that. So if we start with n as our first number, the next number that we would have can be found by adding 2 to that. Because let's say n were the number 16. The next even number would be 18, which is 2 more than 16. So whatever the first number is, we add 2 to get to the next even number. But we need three consecutive numbers, so the next one would be 2 more than this, so 2 more than n plus 2 would be n plus 4. So my 3 consecutive even integers would be n plus 2, and n plus 4. Now we have 3 consecutive odd integers. Here, this is actually going to be the same thing, because let's say we started with the number 3. The next number is going to be 5. We find that by adding 2 to get to that next odd number. So just like with the even integers, the odd integers as well, we add 2 to find the following numbers. And so therefore, this would be the same exact setup as the even integers. Next, we're to write an equation to represent the given relationships. So we're putting this together into equations now. Here we have the sum of 2 consecutive integers is 38. So we have 2 consecutive integers. So integer number 1, we can let be the letter n. So integer number 2, it doesn't say odd or even, so it's just the next number. So it could be like 7 and 8, or 18 and 19. Whatever this number is, the next one, we add 1 to get to that next number. So it says here, the sum of those numbers. So sum means addition. So we're going to add the n with the n plus 1. And we're told that the sum is, which means equals, and it equals 38. So my equation would be n plus 1 equals 38. We have 2 more examples. The next one says the sum of 2 consecutive even integers is 38. So if the first integer we have the letter n to represent, then the second integer says must be the next even one. So we take that and add 2 to it, right? Because if n were, let's say, 20, then the next number that's even would be 22, which we find by adding 2 to that first number. So our 2 consecutive even integers can be represented by n and n plus 2. And then it says the sum of those. Sum means to add. So I add n plus the n plus 2. And then it says that sum is, which means equals. So that equals, and then 38. So my equation to represent that expression would be n plus 2 equals 38. And lastly, we have the sum of 3 consecutive odd integers is 39. And we are told to write an equation to represent this expression. So the 3 consecutive odd integers, we begin by letting the first integer represented by the letter n. All right, so then the next number is going to be the next odd number. So whatever this is, we need to add 2 to it. Because, for example, if this number n were 21, then the next odd number is 23, which I find by adding 2 to that number. All right, and then the next odd number after this would be 2 more than n plus 2, which would be n plus 4. So my 3 consecutive odd integers can be represented with n plus 2, and n plus 4. And then it says the sum of these numbers. Sum means addition. So I add n plus the n plus 2 plus the n plus 4. And then it says that sum is, which means equals, and then 39. So my equation would be n plus 2 plus n plus 4 equals 38.